Hi, we'll just wait for a few minutes for others to join and then start. In the meantime, if I have any questions, I can take those too. Hello, hello. Okay, so question is about polymorphism, right? Right. So, um, right. So in C++, one achieves one achieves polymorphism through the classes itself, right? So we have a class, and it sort of acts as a template for a blueprint for an object, right? Now the instantiation object, and it has some behavior. Now the nice thing is the object, depending on some certain criteria, okay, it can be a certain, it can behave differently. So for example, if we have templates, so depending on the template we have, the uh, object will have different data types, let's say. So let's say there is a data type, a data type is a template. So we can set the template, and then the member functions or the member variables will have different data types. So that is one way of thinking polymorphism. Okay. More clearly, if I say, so there are compilation time. So because template has to be, we haven't covered, so which we will cover, I think today or next class. So during compilation time, you will have uh, sort of like different data types. So one is function overloading, which um, depending on what input parameter uh, you're passing. Okay, so then the behavior changes, right? So in a way, if you think about it, if you have an object of certain data type, it will choose a certain function. And if you have a different data type, you're passing for a certain function, and then it will behave differently. Okay. So this behavior you can choose for for an object, that's basically polymorphism. So operator overloading is what I was going to cover today. And functional overloading is sort of like what we've seen before. Virtual functions also are sort of the same idea, where they actually don't exist, but you sort of like link the function definition and body to while runtime to certain um, definition for that function. So essentially, these are the three kinds. The function overloading and operator overloading has to be comparison time because data types have to be known, right? So yeah, so because you can't have, I mean, a function can have different data types or input parameters. So it has to actually know what are the different data types, like while compilation itself. So those are compilation time. Virtual functions are during runtime. Yeah. Actually, no. There is a requirement also for virtual functions because during runtime sometimes we have a very how to put it. So let's say there is a base class and there is a derived class. The base class is what we will have exposure to. Okay. So it's like let's say the base class has some kind of function. Okay, but its definition is not sort of known. Now, when you, I mean, or think of it this way, it has certain functions which are virtual. Okay. Now, when you derive a class, right, you have another derived class which you're deriving from this base class, you can override those functions. Okay. Now, yes, you can override them um, for when you're actually explicitly overriding functions. Here, there's the other thing. The function that you're overriding actually has to be virtual. Okay. So that is, hmm. There is another way you can override simply. Yes, true. Yeah, that is correct. There are, I mean, we have seen the example also for before where we can override them. Um, yeah, but it's just another uh, way of doing it. Maybe I'm not able to explain it. But yeah, more or less that's it. Another thing is actually, if you think about it, uh, when you derive functions, okay, think of it this way. When you derive another class from your base class, you, maybe I'll write this and show you. Right. So let's say we have a base class, right? And there is some derived class. Now, suppose there is um, an object, okay, defined as base B. Okay. And then, yeah, as the autocomplete says, um, there is some derived so this base B will act like I can always create a derived class. So think of this derived. I'm not talking I won't be too much syntactical, but think of it like this is the constructor for that derived class. Okay. When you're calling it, and B is the one which will store that object. Base class can store it. Okay. So any derived class you have, any kind, you can store it in B. Now, B is what we have. Okay. It's a constant and current. Okay. A lot of things has changed. Let's see. Anyway, that's fine. Okay. So now imagine the base class is not templatized. Okay. And your derived class is templatized. There's some template parameter it takes. Okay. Now, because your base class is not templatized, you can set maybe if my template is something, okay, let's say integer, yeah. Then I will set it to be. I can also do this if equals to double, yes. Okay, so I wanted that. That's good. So if it's double, then I'll also set it to B. Now you might think that I'm actually just repeating code. Yes, but doing the same thing, but you have to be separate. You have to understand here, T is something, okay, which will be constant for the derived class, right? But it is not known by the B, the base class object. It is just an instance of derived for a specific case. If it's integer, it will still be B. If it's double, it will still be B. But if I'm using the functions from B, like there is some function and passing parameters or whatever, I don't need to worry about any of this. Yes, for derived class, the template is known, but sometimes you want to have a base class where the template is actually not known, okay, during compilation time. But I want the optimizations also, because if things are known at compile time, it will do the optimization of all the class details, everything in the derived, right? Okay. But no, that's the thing. It's not exception handling. There is a whole class itself. So exception handling is essentially like throwing errors if something is not there, or if it's there is some, in a way, if there is an issue. Here that's not the case. Here we're worried about what will my compiler do when I have integer as the template. So there will be a lot of functions and variables inside derived. So it will optimize for that and set it to B. If I want my T to be integer. If I set my T to be, let's say, now this is known, let's say from some parameter during runtime, that T will be this. Okay. And T will be double. So here I won't say integer. Let me explicitly write it as double. Okay. So don't be confused. T is known only at runtime. But the good thing is, because my code will optimize all the functions for derived or for integer, okay, during compilation itself, it will also do it for double. It will do for every uh, template parameter you already gave it. Okay. Now, only during runtime, it will set either this to be or this to be. That's it. There is an object. Think of it this way. There is an object V, which is an object. Okay, let's not think of B. There is an object, some temporary object derived integer bracket. Okay, optimized for integer. There is an object derived double bracket. Okay. Each of these is set, it's already optimized, and we have, let's say, a huge list of it. Okay. During runtime only, I can just set it to be. And which one will get set is just known from the parameter. Let's say there's some input parameter we're given to the code. The good thing is I can have optimized code just by changing parameter also. I don't need to worry about them being compilation constant. Okay. That is the reason to have um, derived classes as templatized, but the base class is not. Like this is one use case. Okay. The second thing is now because your base class has virtual functions, and let's say there is especially the function FUNC, right? This is virtual. Whatever my derived class, it has to have this function. I don't need to change it. I can just call it now. That is actually the reason to have virtual functions. It automatically takes care of it. That's more or less it. Now, main thing is, yeah, it will essentially like uh, it will work. You don't have to worry about modifying the old code. That's the base class actually. Yeah. Yeah. Sort of the idea. And polymorphism and well, mm, that could be if uh, simple one. I'm not entirely sure, but this is one way that I'm at least familiar with. There might be. I mean, on top of my head, can't think of right now something. Right. Okay. Um. Yeah. Okay. I guess I can start with the topics. Sort of a recap. What we saw last time. There, the first thing we saw about was basically we're talking about cost casting. Let's say we have a function which is print. It takes a string of characters, right? Character pointer, and we just output it. That's all. Now, the actual character, the object, right? C is of character is a character pointer, but also a const. It's like a const character pointer, and that is the hello world. If we try to print C, just pass this, it'll throw an error because we can't pass a const character to a character pointer. Const character pointer to a character pointer, right? What it does is it demotes that. It's basically saying I have a string now, which I can modify, and that is not allowed because this is already const. Now, to avoid this, uh, we can use the const cast it to a character pointer, and then pass it. Okay, so this is allowed. So to pass around, so to pass to functions to temporarily disable sort of the constness, one can do this, the C++ style way. And the C style will be just using brackets and character pointer. The next one is this one, where we had a class. Okay, it takes an input, sets it to internal variable I. Is a getter function. This is a setter function. The getter function is const. Okay, setter function is not, right? Now, if you have a yeah, same idea here, that this is what we saw before. Now, let's say I have I declare an object with two, okay, of class A, but as const. If I write a getter function, if I do a getter function, that is fine. If I try with the setter function, it gives an error. Okay, because my object is const. Now I can const cast the object, okay, and then set it, which is fine. But if you try to const cast, but yeah, it's like you can't const cast the object itself, but const cast with a reference. Okay. Next we saw is reinterpret cast. It's essentially like reinterpreting a pointer to some other um, data type explicitly. So long is of we can actually check how much it is. You can I think I did that last one. Yeah, you can check the size of it. It's usually 8 bytes. The size of long is 8 bytes, so at least in 64-bit systems. And the size of double is also 64 bytes. Okay, so one can technically speaking store. So here I'm creating a double and storing it in pointer D. Okay, storing its address. Now, if I try to, I have a long which can actually keep the address of D. So this is basically address of D, and PTRD actually has it. So if I access the pointer D and try to store it in L, both have the same amount of data. Okay, but implicitly C++ won't allow you to do this. So it's one error. So what one can do is you can explicitly cast it, okay, as a long and then store it. Okay, it will basically be the same amount of data, but it's the way you treat it just differs. Okay. To do the same in C++, you have to do a reinterpret cast here where you are reinterpreting the pointer, okay, which is a double pointer to a long. Okay. You can actually use this reinterpret cast to cast maybe pointers of double type to float and vice versa and so on. Depends on your use case, but this is like sort of the idea behind using reinterpret cast. The next one is with static variables, so static cast, right? Not static variables, sorry, static casting, where you are you have some variables like, right? So that was for pointers. So this is for actual variables. Here you will take example of some integers and longs and doubles. So I is the integer where we store 7. L is the long where we store 12. D is a double where we store 4.5. See? Now printing it is as usual. We'll see what happens. When we try to store D, right, into I, there will be implicit typecasting. You lose data, but that's part of what happens here because you're storing double, the 64 bits or 8 bytes to 4 bytes of data to the integer. You can do this explicitly also, right? So this is what we saw before. C really doesn't distinguish how you're typecasting for and actually for what. You just use brackets and it actually does. From syntax wise, it's sort of like simple. You have one syntax for everything, but the intention is lost, right? And that's why C++ has these specific things. So static cast, when we say, we mean that we want to actually type convert, as in we're treating this typecasting this D and actually storing it in I. We're typecasting to an integer. Okay. So there is a typecasting here, yes, through C++. C++ has static cast, but the additional main important thing here is that the intention is also known. Like actually what we want the program to actually do. Okay. Then sort of similar way, we can typecast the integer to double. Okay. Also, you can typecast the same I using static cast to a double. All right. Then we see some pointers too. Uh, we have I, L, and D, integer, a long and a double, same as before. And we create pointers to it. So I need PTRI is the integer pointer, PTRD is the double pointer, PTRV is the void pointer. Okay. Now, PTRI we can store to void pointers and PTRD true. It will not throw an error because essentially we're saying a pointer had some data type, but we are ignoring it. We're just storing the data address, but we have no clue of the data type it has. We can reinterpret the data type, okay, to something else and then dereference the data. That's okay. But that's up to you. It's like if you want to do that. But if you try to do the opposite, where you're storing a void pointer inside some other pointer of some data type, implicitly will throw an error. We can do that explicitly. Okay. The same void pointer we can reinterpret as integer pointer or double pointer and store it. Same thing you can do using static cast. Okay. Where you are reinterpreting it to be integer pointer or double pointer. Okay. So today we'll see operator overloading. It, maybe we can start with the template first. That will be better. Yeah, let's do that. As usual, include string so that we can print stuff to see. Let's say there is a function we'll define integer max. Oh, it already they make it. Okay, great. So let a and b be two integers. Okay, and the return type will be the return will be a. If a is greater than b, then return will be a. Else this will be b. Essentially, a ternary operator to say which one we want to return depending on if a is greater than b or not. Okay. So this takes integers a and b and returns an integer. Now, what if I had uh, numbers, this a and b, but they're of data type double? Okay. So give me the code. Oh, sorry, my bad. Yeah, already gave me the code. So there is a double, sorry, there's a double a and there is a double b. Okay. It takes the same inputs, but of different data types, compares them, and then returns accordingly. If you think about it, the code is exactly the same. You can also write it this way. Just uh, you can have it with ifs also. Yeah, like this. It's essentially the same thing. Actually, the brackets are also not required. Okay, up to you. It's essentially up to you however you want to write the code. But if you think about it, the code is exactly the same. Okay. The code is exactly the same, and you're just repeating it. If you think about it, you had to write another function, okay, just so that you can take different, I mean, you have different inputs, but because the return type also changes, you have to write another same lines of code again. Okay, just because your data type changed, your body and everything more or less stays the same. The code logic doesn't change, nothing. So to sort of avoid this, okay, use compiler, decide using T. Yeah, that's the template. Exactly. So what we're going to do is make templates and then use them to do the same thing. Right. There is another way one can do this. So let's see that. Then maybe can appreciate templates better. Include the IOStream files and use macros as defined. Yep, that's exactly the one I want. So we'll have the max instead of the function. I'll have a macro called max. Okay, but maybe I'll not call it just max. I'll have them. Okay, I'll have them as capital MX. Takes A and B. Okay. It, uh, then this is the body of the macro where compares A and B and returns accordingly. If A is greater, then A, else B. Now I can have uh, I can have a main function now, okay, where standard C out is something like this. Can compare one and two, okay. I can come, let's say pass one and two, which are integers. See the previous, if we see the previous example where we had max for two integers and two doubles. So let's say I have two integers, I'll take max of it, and accordingly it will return the same. Anyway, it will just copy paste the code, compare it, and then put it here. I actually don't need to write two separate functions because the macro will automatically take care of just inputting the like the whole line or the body of it itself into this text. And similarly for the double also. So in a way, you can actually shouldn't line 7. Do you mean line 7? No, it won't. The reason is it's a macro. So macros take inputs. So this is the definition of that macro. It doesn't care what A and B is. If you see here, we haven't told here what is the data type. The reason for that is macros really don't care about data types. They are simply preprocessors, as in if there is a text A and there is a text B, and here the text is 1.1 and 2.2, will simply put it in these places, okay? And whatever is inside the yellow brackets, it will just paste it here. So essentially, it will look like 1.1 greater than 2.2 question mark 1.1 colon 2.2. So after this preprocessor unit is done, then the compiler actually compiles. When it is actually compiling, okay, it sees this line with all these variables, then it evaluates it at compilation time and then does all the optimizations. Yeah, exactly. So that is the beauty about macros, where things happen even before compilation also starts. Okay. When I say compilation, I mean uh, understanding what standard C out is, what it means, okay, to assembly and then maybe into machine code, etc. If or any other optimization a compiler wants to. Before any of that, preprocessor directives always take priority, like hash includes and hash defines. Okay, you can give string as a parameter, absolutely. But then the problem is the greater than symbol should be defined for that string, whatever we want to have. So ideally, for strings, greater than symbol doesn't mean anything, so it will throw a compilation error. When let's say A is the character A itself, and B is character A itself. So that's what we pass here. Then the problem is, well, compiler compiler will see A being compared to B, which if it means something, then it will, if it's true, then it will return that, else not. ASCII values, yes. Um, from character perspective, I guess one can compare characters too. So yeah, it probably will be always true as far as I understand. Yeah. Then it will return only the A, all the whatever the first argument is always. Right. Anyways, the main thing to show here is how do we exploit templates to do the same, which is a very nice and neat feature of C++. And one doesn't need to always rely on macros. And the thing is, macros are one dangerous. They can introduce bugs, right? Second thing is, uh, it's always not may not be possible to use macros for all the cases. Okay, so let's see how to do it the C++ side. Okay, so let's actually include a string and make a template. Okay, I'll call it type empty. Okay, that's fine. As usual, this is the code exactly what I wanted. So I'll have, instead of writing all the codes, whenever I see the data type, okay, I'll use a template instead. So the data types are doubles and integers, right? So instead of those, I define a template before writing the function, okay, and just replace it then with the data type I want. Code is exactly the same, okay. I'm comparing or returning with a ternary operator. So the T is the template that will decide what my function will look like. What will be its return type or whatever it will take in. Right. Now let's write the main function. All three still has to be same. Yes, that's correct. Now that is known because A is of type T. B also has to be of that same type. And the return is also has to be of the same type. Yes, that's correct. Because we have used T and not some T1, T2 or something. You can have multiple parameters and you can play around with the code. But currently, this code enforces that max can only take the same kind of inputs and return the same type. So let's take an example. Let's say A equals to 6 and yeah, let's say B is 7. Why not? And then yeah, let's have C is 6.1 and D is 7.1. I don't understand the question, but okay, let's see. We have an inventory object. You can assign inventory dot amount, which is an integer in T. We will see how to use this. So I'll actually modify this code now. The way to go about this is, first of all, we'll see for functions. Then we can actually use templates for classes also. Yeah, I think I got that. So you have a class which is templatized, and depending on how you instantiate an object, okay, with whatever template you want, your functions and member variables will also get instantiated. So here I won't actually use just max, okay. I mean here, okay. So technically speaking, um, you can use max, and the A and B data type are both integers. So here the return will be integer. It's implicitly known. Let's run it and see. Okay, so this thing is with 9. Okay. All right. So yeah, classes can get confusing. We'll come to that. So let's take step by step. Here you have A and B, which are both integers, and max is just a template. So if remember from line 3 to this line 11, this function actually doesn't exist. As in, if you would have compiled this code, in your code itself, max with something taking integers A and B and returning integer with this body, okay, will exist in the executable itself. There will be another max which takes two doubles, and returns a double with this body will also exist in an executable. But when you have a template, and let's say the max lines never get called, this function will have the max, right? If it's a template function, nothing will exist in the executable. As in, compiler doesn't create a code at all for a template function if it's never called. So in terms of memory, it is also efficient. Second thing is, let's say I just uncomment this where I have integers. It will only create a code, okay, where integer function max with its body will be there. There will be no code for the double because here we only call for integer. Got it? So if I have both, then compiler will create max for both of them. Else it will only create for those which you are actually calling. That's the neat part about templates. They actually generate code sort of like on the fly. Right. When I say on the fly, more or less, I mean only if the corresponding template gets called, then only it will generate the code. It's a very simple example. You can have more complicated code where depending on a template, code will get generated inside the body. Yeah, you can have various examples. Here you can actually pass explicitly that you want integer. Okay. Here too, you can say you want double. But it's because here it is implicitly known. You actually don't need to pass it, but nonetheless, you can also do this. Okay. All right. So that is one. Let's say what happens when we do this. So I'll say output. Okay. Yeah. Okay. So that's what I want. And yes, let's print it too. Yeah. So output O will have A and B. C and D are in P. And then we can have the output. Okay. So here it will interpret whichever uh, output it has. So O is integer and these are integers, so that is fine. The return type for max in this case is also double and you are storing in double, so it is all good. Right, it will be same output. But let's say I change it to this and to this. Just need to change them and then try to print. For printing, it doesn't matter what you're giving because it will just print whatever O has or P has. But what about these lines? Let's see. Yeah. So one has to be careful. In A and B, it takes integers, yes, and the max of it is 7, right? The return type will be integer. because that's what the template says. But when I say it is a double O, then here there is an implicit casting happening where where a integer is being stored into a double. Okay. Right. The second case, I think you can take a guess. Here also implicit casting is happening. But from int to double, here it's from double to int. Yeah. Now, because a double is being casted into integer, that's what we see. P has only less digits. So let's make it like 8 so that the things will be more clear. So yeah, basically the decimals get dropped off. So what we have in P is demotion of a double to an integer. Okay, that happens implicitly. But remember, max itself will always return the same data type it has inferred. So it inferred that here to be doubles it's taking, so it will always return a double. Here it is taking integers, so to return an integer. Now what happens after this return to the left of equal to, right? That is casting or not casting or whatever error it will throw. Okay. So that's the nice thing about templates. Okay. Where you can have the same structure written once and used for different data types. Okay. Awesome. Let's take the same thing, but now we'll use it for templates. Uh, sorry, we'll use the templates, but with classes too. Let's say I have a template. Okay. P. Oh, sorry. P classes and let's say define mm, I think we'll use this. Okay, let's go with this. So template is T. I define a class called max. It has two member variables A and B. Okay. This will be private. Their data type determined by T. This is the constructor. So T takes, so max takes T of A and B. Okay. It sets the its own A and B. Okay. To the inputs A and B. So this right hand side are the inputs. Okay. Whenever we have this with arrow A, it refers to its own variables. Okay. So here A and B are defined. Okay. Line number 3. Those are the A and B's is with this with the keyword this. Okay. And then when max is called as such without any inputs, okay, it returns in one of this with a basically this body. Let me separate this. Okay. So the max returns this ternary operation. Okay. The other thing is you can have the greater than operator. Okay. This is what the operator greater than has been defined. It takes the object of max and returns A and B. Okay. This is how the class is written. Yeah. Then we can have the main function. So a max was defined, okay, with object M. It took two integers because this is the integer template that has been defined. Okay. Then sets A and B. That's the construction that is done. The next thing you can do is call max of this object. That is the max function that we have defined. Okay. And then see the output. Okay. Templates with classes have their own way of writing syntax. One just has to get familiar with them. Okay. Sometimes, okay, so the question is about this keyword. Um, Sometimes you want to refer to that object's pointer. That's what this is. This keyword this. Here in this case, do not get confused between A and B. Okay, so here the local variable is A, and here we actually want to refer to the A and B of the private members. That's why this was written. Honestly, this is a generated code. So not normally I wouldn't write it this way. I'd rather give them different names. So underscore A or underscore B to the inputs or give it some other name PQ. But this is a valid code and you can also do it this way. Yes. Now to say, is there a particular reason to do this? Not always, as in if you have different names and you're keeping tracks of variables perfectly, there is really no reason to use this at all here. Yeah. Okay. So let's run the code and see. All right. The header files file were not included. So, all right. Um, Lot of error codes. Okay. Let's see. Hmm, all right. We never said if it's public or private. Hmm, that's one. Then these are not syntax. This one. That should be a class. All right. Event. That's I guess should be okay. Oh, sure. Yes, it needs a type name. Right. So let's do one thing. Let's call this as M, and here we can call it next. This we can move to the private, and that should be yeah, that's fine. So right. So okay, yeah. Something I cooked up fast. So again, this is also one way you can actually debug. So compilers give you error codes. So you just keep going to one by one and then fix this syntactic errors. But essentially, this is how a templated class will look like. Okay. We have a class, max. This is its constructor. Uh, Member variables which are private. Okay. Constructor has to be public. And also a max function that we defined, which has a return type. There's an operator which takes object max and then returns this. So we can also do that. And yeah, let's see if that should work. Font does, I believe it has to do this way. Not entirely sure if it will work or not. Mm, yeah, this will be very weird. Yes. And let's not worry about it. Right. So that was one example how to use templated classes. What I want to show is, okay, maybe I'll not call it this class. Yeah. the- Okay. I hope this one is clear. Yeah. Operator is the next one I'm just going to talk about. Yes. So operator overloading. Okay. This one I won't compile, but I guess sort of you get the idea. There'll be a type name T. I should node IST. Okay. Now here there'll be class. Says C. Now inside this class public, I will have uh, let's say uh, P and B. That is some variables. That's fine. There's no need to set anything. So what I'll do is I have an operator equals to defined as this, which takes integer x. Okay. And then sets b equals to b plus x. The other one is operator, okay, equals to same as before, but the double. But this time it won't set b plus x. I wanted to do b plus 2 times x. Let's say. Now this class C, okay, or maybe you can just call it that's fine, whatever. Now I have to remember variables a and b for this class. It has the default constructor, destructor, everything's fine. Specifically, I have this equal to operation. Okay. Which essentially means, which essentially is this actually. So when you uh, write in I equals to 5, okay, or this one, double is 5.5 or something. What happens is, think double or integer also to be some kind of class. Yeah. Now the equal to is an operation for that object. So operator word with the operator symbol, the greater than or the equal to anything, is how you define what happens in this operation. So we have taken equal to for granted for now. As in, we understand that it sets the variable to it, some value or something. True, but we have also seen the equal to being used for derived classes and public, like the like I was saying about this one polymorphism. So this is a base class, right? And then this is equal to a derived class. So you're setting an object to this class P. What is actually happening? So this equal to is what sort of like takes care of that. I mean, there is an equal to, so it has to know what to do with this right hand side, right? That's what we are getting at here. So depending on for this class C, okay, so let's say I have class C's object as obj. Okay. Now I won't compile this, but uh, probably get the idea if I just I mean what will be the output for each of them on right now. So if I have the object, okay, um, equals to, okay, and let's say there is 5. Yeah. So what will happen is, because 5 is integer, okay, let's not with 5, so 3 and object not 3.5, 4.5. Okay. So because in the equal to C is, yeah, that's how much? Because equal to C is, let's clear this, equal to C is integer, it will use this definition of operator equal to, which says, and imagine that this object has created and A and B's were set. Okay, so imagine all that happened. Maybe I can do that also. Say it's 3 and 2. Okay, that's it. So the object A was set to 2, object B was set to 3. And when I call equal to, right? So object equal to, it takes the input as an integer and uses this definition. So because 3 is integer, it will set B with B equals to B plus X. Okay. Same with second one, but this time because it is a double, it will use this definition. Okay. I won't run it, but sort of, I guess you get the idea. This is what sort of the idea behind using operator is. This is operator overloading. Yes, you're overloading operators, which is the equal to and here. But depending on the input it takes, you can have different data types. Object is assigned to TA. Yeah, this is also one has to be careful. What is the data type that we have? We can have it at A as an integer or double. One of this. Again, this is not C++ syntax. I'm just writing it as a uh, pseudocode. Okay. Now you can have the template of the class to be something that is fine. But here I'm saying it's not the template that I'm actually enforcing. So what I'm saying is if it is integer x as the input for equal to, okay, then it will be this will be the body. Else for double, this will be the body. That's all. Here, if you think about it, the template T doesn't matter. Okay. If it was templated, good. If it is not, then T will be whatever. You can fix it. Let's say if it is templated and there is a T, we are fixing it here, then the operations here will have to will have corresponding castings. Okay. Yeah, we did not. We just used it for A and B, is what I'm saying. Yeah. Now the thing is, because of the template T, these variables get the data types. Yes. But in this body, X is an integer. B can be an integer or a double. And when you're adding double to integer, you get the idea. And whatever is B is. So all this implicit casting will automatically happen. Okay, same for here. All right. Okay, I'm not familiar with C sharp, but I guess, yeah, probably yes. Okay, right. I think this uh, templates, um, the class templates, the operator overloading. I think you get the idea. I mean, sort of it's clear. Let's take another example again. This I will also just to show I'll write few things. So let's have the vector. Okay, nothing fancy. This time, let's start with the yeah, sorry, the main function. Okay, the standard vector. Okay, I don't need the full thing. Let's just say this is A is of size 10, and yeah, sure, why not? Uh, each of with values 1. Sure. I want to set it though. So let's not do it. I have the usual for what we used to do, n equals to 0. Yeah. Set all the 10 values to ith position. Okay. Now here, the important thing is in the standard vector class, okay, standard is the namespace, vector is the class. It is templatized class with an integer. Okay. Now this class has its own operator. Okay. As this, and there is a body. I'll comment this out. Okay. This is just to show you what it actually is doing. So it will take an input. Okay. Like it is saying, it is overloaded. So the bracket operation here, okay, takes an input which is size underscore t. Okay. Let's call it I. Why not? Now that is the return, but what it actually means is a return of, so we have the original pointer, right? A dot data. This is the actual pointer to A. Let's think of it like there is a okay. So the the function data will correspond to the pointer starting to A. Okay, which is the standard vector. For now, I'm just calling it A dot data to make it clear that that is the one, but there could be some internal variable also. So it could be such that the A dot data, okay, is stored as underscore a pointer. Let's say this is just an example. So I can use it here also. Okay, it probably will be used, but so that you don't get confused, I'm just writing it this way. So the pointer is actually stored in a underscore pointer. Okay, and then we do some arithmetic, pointer arithmetic. Yes, we add I to it. Okay, this is basically the I. It takes, so it's an integer, yes, but it usually accepts let's say size underscore t, so that the largest number it can do. Then adds that to the pointer. Okay, then we just dereference it and return that. So essentially, when you call a with bracket, big brackets I, okay, essentially this is what the code looks like inside the class standard vector integer. Okay, which says there is a return of which is there is a function operator with brackets takes size underscore ti. What is the body? Now it is a return of dereferencing the pointer plus I. So we add do the pointer arithmetic. We will shift the pointer by I units, whatever the input we are giving, then dereference the data and return it. Our shorthand representation is essentially this. Okay. Instead of writing doing pointer arithmetic and then dereferencing, there's a simple way of writing things. Okay. All right. Yeah. So that's more or less, yeah, this will be the output. That's fine. That's more or less the topic about templates and the macro, how we can do the same thing. So essentially the usage of it. Okay. How do we define templates, and here we define the template and then um, use it with implicitly known return type. Okay. And the input also. List of data to T. Um, Usually no, because it's just a type name, so it will accept only one data. But what we can do is uh, instantiate different objects of different data types and then store it. So, like I showed here, uh, I'm creating derived with, let's say, integer, double, and so on, and then storing it in the same B. You can have different objects and not have the if statements. You can have B integer, B double, and so on. You can do that actually. Any other questions? You can do another thing also. Instead of just having one template parameter, you can have multiple, and depends how you want to write the code. That also is possible. Yeah. Okay. You have one template which has T, and I'm using that template T in three classes. Okay. So you during runtime, if T will be integer. Depends. Actually, what is the code? Maybe you can put that. I can try to answer. So you can actually use the same letter T for three different classes. Yes, that is allowed. Now, the important thing here is that let's say you have a class A, B, and class C, and for each of them, so let's say um, this one, yeah. So I have a class here, max. Let's say I have class A and B and C. For each of them, actually, I can just have the template type name T. That's absolutely allowed. So this capital T, let's say is written for class A, it is for that class. Second, similarly, when you have template type empty for class B, it is that template is for that class. This basically this letter capital T. So on and similarly for class C also. When you instantiate an object like this way, the small m is the object. I can have it for A, I can have it for B, I can have it for C. I can for A I might have integer, for B I might have double, and so on. The letter will correspondingly be adapted for each of the class, whatever is the input. Okay. Yeah, that's what one has to understand. Templates are compile time constant. This is very important to remember. Templates cannot be changed. So in this templated class, when I construct the object M, I have to give a template here. This one cannot be some variable. As in, I cannot do this. Type name T. I think this is allowed, but let's see. I wanted to throw error at here actually. This is the class template. I did not run it. Oh, sorry, my bad. Yeah, I wanted to throw error. Okay, not here actually. So let's go with this time. I think this should be okay. Qualified name. Yeah, not type. Type maybe. Yeah, this should be fine. It will be fine, but yeah, this will be fine. I'll probably not get an error. Unknown type T. Yeah, that's the thing. Yeah, that's exactly what. So here, that will be type name. Yeah. Okay. Think of it this way. Let's say, for example, I was able to define T somehow. Okay. Uh, that declaring it as type name T throws an error, but imagine for some reason I can do that. Now define the type def is basically saying so this line is valid. I'm just saying trust me. So it's like treat my capital T as integer. Okay, this is basically what this line does. And I'm passing that to T here. Say, for example, this T was able to change to double later on. I will, sorry, I'll comment this lines later just to show an example I'm putting it. Here should be integer. So let's leave it there and then yeah. So this is the example I'm trying to take. If T is something, so let's say it was integer at once and then first and then I do this. I change T to double somehow. Okay, there's just imagine that it can be done. And I do the same, but declare an object T and let's say passing different doubles. So this is not allowed because templates need to be known at constant compilation time. Let's say for some reason T is constant and let's forget this code exists. T is constant and known to be double at compilation time. Okay, or like somehow, then this is a valid code. You can pass T here and double will be sent to the template parameter. That is the important thing. Templates need to be known at compilation time, all the parameters. So here we have just one template parameter. All the parameters in the template need to be known at compilation time. So hence, if I have some T, which is a variable, so it changes to integer in one place, double to one place, and I'm trying to pass it to template parameters, that is not allowed. Okay. You can have, let's say this is not max, but some other function called min. Again, similar idea. It's not allowed because T needs to be known at compilation time. Okay. Yes, you can. You can have as many template parameters you want. You can actually mix and match. So here we're trying to compare values with the same parameters because it's an integer, it's a maximum or a minimum or so on. You can have other functions also. Yes. Yeah, go ahead. Yes, you can have T1. So the capital T, think of it as another variable. You can have this way. Maybe I'll make another file. So this is T1. We type in T2. And yeah, let's go with this code. So there is a class called main. Okay. Yeah, you can do that. So you can have different internal variables of different data types, T1 and T2, right? Yeah. And define this way. Yes, yes. So define as A and B. but A is of T1 type, B is of T2 type, and then so on. Like the whole thing goes. Yes. Now one has to be a little careful because min and max are actually compared for the same data type. While yes, I have written a code like this, it will have certain behaviors. One has to be careful when trying to compare stuff of different data types and return, right? So return will be like A and B. So return is again decided by the T1. So one has to be careful what T1 was. T1 is the data type A. So if it is true, then the return type of A is always gets returned, which is what A is. But if it is not, then B gets returned. But B is of data type T2 and you're returning it as T1. So again, one has to be careful of these things while trying to code. You can mix and match, no doubt, but uh, each line you have to be careful what actually it means. Okay. Yeah. Hope this is clear. Yes. Any other questions? I think I'll cover more or less this itself today. So if you have any questions, you can ask. Yeah. Awesome. Yes, you can. So since vector takes templates, you can actually make the vector itself as a member of uh, our class. So okay, let's take this and then extend it. Yeah. For now, let's have just one template parameter. The class will call it as A, and instead of mix and main, okay, I don't require this. So standard vector V, okay, of template type T. This is the vector V, and I'll include vector class. So yeah, that I guess is it. Yeah. Now the nice thing is this is a member variable. I can have some function void, okay, or let me call it init. It initializes the vector, okay, with taking a size underscore p value and let's say yeah. So it essentially initializes v. It takes a n and resizes it to n, and this is my vector. This is my vector. The nice thing about all this is that it works for any data type, and it just depends on whatever my data type of the class is. Automatically, the data type for this vector v is known. The resize also take care of how many it has to resize, and the total bytes it has to allocate is already known because of the data type of the vector. Yeah, you can absolutely do this. So yeah, you can do something like a object, okay, and but this one has to be known. So let's call it integer. Okay, so object dot init. Yeah, and let's pass 10. It will resize that and then create it. So let's call it G. Right, private members. So let's make this as public. All right, then we can call init. So it inits. So the init is called. and the vector gets resized to 10, let's say. Yeah, a, like you said, a. Maybe let's make it a. Yeah, sure. Okay. Let's keep it B. The vector is fine. Yeah. This is also clear. Yeah. This way you can um, use templates to even initialize member variables, which are themselves templatized. Yes, this is absolutely allowed. The other question. Yeah, so thing is, can uh, so yeah, it's ideally not good to mix them, but sometimes if you want to, yeah, sometimes speed up C++. Well, technically speaking, C is, I guess, slightly faster than C++. How much is that? Again, there are benchmarks available online. You can look that up. But sometimes what happens is a lot of external libraries are actually written in C or Fortran. So let's say matrix multiplication libraries like BLAS, uh, whichever your implementation is. For example, Intel's MKL or Netlib BLAS or any other such example. They are written in Fortran. Okay. There is a C BLAS, which is essentially the same BLAS written in C. In either case, like in all these cases, let's say you're writing a C++ code and you want to use those functions, okay, in your code. So there one has to be, you're actually sort of like mixing Fortran code or C code inside C++. So people use something called extern C, looks something like this. So you define extern C and then, yeah, something like this, word start, main, and end. So, yeah. Yeah, ignore that. Anyway, so this is some function. You can actually ignore the main also. Let's say it has some body. There is some body to it, and then the code ends. Now this uh, function underscore start exists. Let's not call it start. Let's me call it multiply with some input. Let's not worry about what the input is even. The point is this underscore multiply exists in some other external library. Okay. What usually happens is if it's a closed source or open source, in either case, you have the compiled object of the code. Okay. And there are header files for that. So you include your header file. Okay. So this is the hash include some header file. Okay. External header. Let me just call that dot h. So this external header has this function multiply, underscore multiply, let's say. And the body of it is compiled and stored in some object. It's some object file, the .o file, right? Now, to use that function and link it to my code, because it's a C code, I have to use extern get that function defined here and then use this. To even access this function, I can include the header file, corresponding header file. That's all. So a lot of times it's not always about speed, but about maintainability and portability and backwards compatibility. So a lot of times these old codes which have been written long back, uh, one actually doesn't need to rewrite them in the newer language like C++, because you can actually call them uh, and link them through syntax like this. And anyway, they have been quite optimized in written in C and Fortran, so and so on. So yeah, you can just link it, call the library, get the code running pretty much the optimal speed you can achieve, like the pretty much the optimal one can do. Yeah. So that is the mixing here. Yeah. So, any other questions? Yeah, I can do that. Sure. Any other questions? Private inheritance. All right. Yeah. Right. So usually what happens is, if you have an object, there's a class, okay, we have instantiated some object for it. Data types are three types. We have private data, so nothing is done as private. We have public, and here it says friend, but there's protected also. Now, private, always remember, private data is always local to that object itself, or to that class itself. Okay. Now, public data or public functions also goes for functions. They are accessible outside the class. Okay. If it's protected, then it is accessible by the derived classes of that base class. Okay. Now, if there is a friend function, then uh, let's say this is a display the friend function. That function has the definition outside. Okay. it can access the member variables, even private member variables. So that's what a friend, sorry, a friend function is. Okay. In inheritance, again recapping, data 1b, data 2b, data 3b. I have three data members. Data 1b is private, data 2b is public, and data 3b is protected. Now this is the base class called base. Okay. Now I'll have another class derived, which is derived from the base class called base, which is itself called derived. Okay. Now I have data 1d, which is private. I have not written anything, so it is private. Data 2d is public. Okay. And there is a function func, okay, where I'm using this operator. Now, what this operator will explicitly do is access this data members, data 1, 2d, 1b, 2b, 3b, and so on. You just access them. Private base. Oh, okay. That one, I'm not entirely sure. Oh, sorry about that. Yeah, I am not entirely sure if that is allowed. Let's see. Because when you're trying to derive a function, it has to be public. So let's see. Yeah, I'm not entirely sure which one, uh, which part is it? Maybe I can take a look. Do you know which lecture is it? Yeah, sure, sure. Okay. Um, what I understand from, at least I'll maybe summarize what I understand from private inheritance. Essentially, what happens is when you're instead of using the colon and then public and then deriving from the base class, you're and that's okay. I think that's fine. What happens is you're using instead of public, you're doing the like you showed class derived colon public base is usually what we do, but instead we'll have class derived colon private base. Okay. So what happens then is all the public and protected members of the base class, okay, they become private members of the derived class. So normally, uh, the member variables of the base class, okay, they sort of retain their um, access, okay, with respect to the derived class. In the sense, okay, actually, if we come to this example, here, data one is private for derived, data two is public, okay. But when I do this and then access data one, I can because this is public, private to it. Data 2D is public for derived, so I can access this inside and outside. The data 2B, now here's the important thing. Data 1B I cannot access because this is private for base class. So in both cases of both cases where this word here, line 14, is private or public, one cannot access data 1B in both cases. Okay. In case where it is public, this public will still data 2B you can access here, yes. But the uh, member, so this variable is public for derived. Okay, because it is derived as a public inheritance. If it is private, this variable, okay, for this derived class becomes private. Same for protected. As in, you can access them inside the derived class, but the difference is that the what do you call it? The public and the protected members of the base class become private for the derived class. Yeah, that's essentially the difference between using a public inheritance or a private inheritance. You can cross check with the lectures, but this is sort of what I understand from this inheritance. Base further can't be inherited. Not exactly. You can inherit the base to some other class. So here, the derived class uh, was inheriting base through public inheritance. You can have derived two. So let's say this is one. You can have a derived two class, which uh, oh yeah, in that sense, yes. If you're making a chain, yeah, exactly. That's correct. Yes. So let's say I derive another class called derive two from derive itself. Let's say, yeah, yes. So there is nothing, yeah, exactly. Everything's private from the base class. Yes. It can derive things from the derived class. So let's say there's a third class now, which is derived two. Okay. Level two as it. Okay. For that derived two, it can inherit public or protected of derived class, but nothing it can derive from base class. Yes, that's correct. Because everything has become private. So derived two ideally should also have the members of base class. Okay. But since it was done private inheritance, it won't have. Correct. That's correct. Yes. Actually, that's the good way of thinking about it. Because if you go like a chain, then the inheritance becomes more important. Then actually you'll see in the later inheritance. Yes, that's correct. Yeah. Yeah, that's sort of again, it's like you can actually make everything private or everything public. I mean, in general, everything public, it will work always because whatever you can do with private variables, you can do the same with public. Sure, always. Yeah. The reason to make things protected, private or public is again, it's all about policies and to keep data protected. So let's say you have a base class and there are private members, some other extra, and this is again, I can take the example of the did I take write it? Yeah, exactly this one. So this one, let's say this is a function, but let's say there is some external library which has some class. It has its some it has its own members or something. And usually you don't want to expose the internal members to outside functions. Like let's say I'm a user, I'm using this library. I should not be able to change its internal members. So those variables one should keep them as private. Public parts will usually be the functions so that I can call them. That's it. Nothing else. So it is good to separate out private and public and protected. Depends on use cases. It takes a while to, I mean, more or less, if one is used to writing codes, you sort of get an idea which ones you want to keep as part. So that as to avoid errors comes with practice mostly. But yeah, like I said, for only for sure you want to keep it private, else you can make it public. For writing most codes, yes. If you make everything public, you can access everything everywhere, so you don't have to worry. That is true. But again, depends on what kind of code you're writing. If it's in production and all, then absolutely you have to be careful because you don't want some function to change this library's internal variables. That should not happen. Okay. Awesome. Great. I hope you like the class. So yes, happy coding, and I'll see you next class. I'm glad to hear that. Thank you.